Welcome to the School of Batman, a podcast where we ask academics to help Batman fight crime using their research. I'm your host, Chris George, amateur scientist and professional Batman enthusiast. Today we'll be discussing the case of the mysterious rock. We're pleased to be joined by Nanna Asgeirsdottir, who is studying for a PhD in neuroscience, specialising in learning and memory from Florida Atlantic University. Nanna, we'd like to start the podcast with a bit of background on yourself and your research. How did you come to neuroscience?
So I was studying psychology at FAU, and I was kind of forced to do a DIS, which is an direct independent study under a professor, so work in a lab for a semester or two. And I accidentally met the professor I work with now, so we just hit it off, and I just kind of absolutely fell in love with the work that he was doing and the stuff my colleagues were doing in his lab, and just one thing led to another, and I got my undergrad degree, and then I got a master's in psychology, and then another master's in biology, all while working towards a PhD in what's called integrated biology now, a different program. So we're trying to find similarities between how rodent memory works with human memory. So we can actually utilize rodents and other animal models, for instance, to study human memory. So ironically, we don't actually know how memories are formed, so we can use these little adorable creatures to learn how the basic memory functions. So what I'm focusing on is trying to find neural correlates of object memory or memory for items within a structure called the hippocampus. We already know, we have tons of research showing that the structure, the hippocampus, processes spatial memory. So it's the structure that you use to navigate from A to B. You use this structure every day to get from home to work. So I'm trying to find neural correlates for other types of memory.
So when you say neural correlate, does that mean this is the same in rodents as this is in humans? Is that what that means?
Well, mostly looking at specific individual neurons within a structure, and we can analyze their activity and correlate that with the animal's behavior. So we can't do that with humans yet. We can't listen to or see the activity of one specific cell when an organism is navigating or doing something in humans, but we can actually do that in rodents. If you were to turn off the structure in you guys, you wouldn't know where to go. You wouldn't know where you are. You'd be like, I have never been here before. I don't know how to get home.
Yeah, so for like analogies that I can like relate to me, it's like there are certain like video games from when I was a lot younger that if you put a piece of paper in front of me now, I could draw the map of that level, right? But like I don't understand how that works, how I can draw that map. Is that roughly the same kind of idea?
No, exactly. Except, well, case studies have shown that it's not always the case, especially it depends on the duration. So if it's a map you learned to draw 2 years ago or a place you visited 2 years ago, then yes, that is 100% dependent upon that structure.
What's like the goal of what you're trying to do? Is it that you're trying to say that, is it just trying to make that rodent-human correlation to then be able to do more studies on how this actually works? Is the goal that you're trying to say this actually does relate? So what goes on here does go on here. That's like a step one of a path, right? Mm-hmm. So what would be the step two? So you say, yes, this does relate.
It would be to further go into learn more about how these neurons within the structure connect and how they communicate. And because it's harder to do that within humans, but we have, thankfully, tons of rodents that we can research. Then we can go ahead and look at how these neurons are connected and how they are communicating, how they are storing newly learned information within the structure, because we basically don't even know that.
So let's dive into your story. Which Batman actor have you chosen to be your Batman?
Ben Affleck.
As a dark and tumultuous evening of crime fighting draws to a close, the Batman returns home to the Batcave. As the Batmobile parks up, Alfred greets Batman with a beverage and also some bad news. Removing his cape, Alfred informs Batman that a break-in has occurred whilst he's been away, although mysteriously nothing was stolen. Batman surveys the cave, and an ominous alarm starts to ring from his cowl as Batman tries to understand what has changed. Okay, so great story. Something has changed in the Batcave. A mysterious rock. So first of all, how would Batman have known that something had changed? Something is going off in his cowl. So I'm assuming he's able to register a change in his environment. Is that a technology? Is that a neurological thing? What is happening there?
Well, before you notice a change, you have to have kind of an expectation of what it's supposed to look like. So you have, you basically have a map of your environment, of the things that you own and where things are. And you have to compare what you were seeing to the memory of what it's supposed to look like.
So in an intimately kind of familiar environment like his Batcave, where it's just him, Alfred, everything has a place, and he has been there, every day, all of his life with no other external stimuli. Something as ostensibly inconspicuous as a mysterious rock, which, as it turned out, was a secret listening device to try and track what was going on with Batman. That might stick out obviously a little bit more than usual than a rock just walking along the street.
Right. So when you are in such a familiar location and you notice a novel item, a region within your brain kind of lights up with activity. This region is the hippocampus, and we know from other research that this structure both represents your environment, so the entire Batcave in this situation, but it also notifies you if something is out of the ordinary, if something's new.
Okay, so would that be, when you say your brain lights up with activity, is that something where I'm consciously registering? So, for example, if someone just, an apple dropped from the sky right now, I would be able to consciously look at that and go, that is an apple and that's novel and that shouldn't be there. But if there was like an apple in the corner of the room or something, I probably wouldn't notice that. But is there an element of my unconscious brain that would be picking that up and start to spike that activity?
Yes. Well, first of all, I assume it is unconscious initially, but then once it gets to your attention, you go and you say to yourself, well, somewhat unconsciously, this is something new, I'm interested, I'm going to explore it.
So, tell us a little bit about how that actually works. If I'm in a supermarket or some kind of different environment, something starts pinging in my brain. It's not necessarily a fully formed thought. It's not necessarily a fully formed word, but there is a definite register that product there, even though I couldn't probably point to it, is different. Is that the same process going on there? What exactly is happening? Or do you not know?
Yeah, we don't actually know specifically what is happening. We just know that activity within this specific structure and other regions that project to the structure are highly active when you encounter a novel item in this situation. So yeah, we all know this feeling when you see something, like a new iPhone comes out, you're eager to get your hands on it and explore it. So we want to learn about these new things and environments. So we enjoy going to new places. Well, most of us walk around and just explore the world. So it's that innate kind of curious exploratory behavior that this structure sparks. Like it's saying, I don't have memory for this. Let's acquire it.
So that's a really amazing and quite profound thought. Is there any kind of brain reward for doing that exploration and that curiosity? Do you get any kind of dopamine hit or something like that for going, I am now going to acquire that memory? Because just the spike to do something doesn't necessarily seem to a layman as prompt enough for that mammal to actually go ahead and chase that.
Yeah, there's absolutely a reward associated with like a internal brain reward, because if this system weren't in place, we would just sit in the same spot all day. We wouldn't go and learn about the world. We wouldn't go explore new restaurants. We wouldn't figure out, oh, this food is healthy, this is good, and oh, let's not go to McDonald's again because that gave me a stomach ache.
I guess I'm just casually talking. What it seems really interesting, I just had a kind of thought as you were talking that this is dealing with the very rudiments of the evolution of Homo sapiens. Right?
Yeah, because if you don't go somewhere, you don't explore new environments, places like that. Like I'm thinking caveman. You don't encounter new mates. There's not, that decreases genetic variety. So it is, I think the brain makes it internally rewarding for you to do that because it is adaptive. It does help you as an organism and does help your species to do that.
So to bring it back to the story, your research is trying to understand the connection between rodents and humans, correct? Yeah. And so what's the advantage of trying to make that connection?
Well, basically, we will be able to use rodents to study human memory. So we can infer things we learn about how the neural connections within rodents function and kind of learn, or assume, I guess, that it works the same way in humans. So we don't have to wait for people to get sick and get dementia and Alzheimer's and all of these awful diseases. We can actually learn about how healthy memory functions in the mammalian system and kind of learn from that. We don't have to study the diseased brain.
Right. So once you've made that connection, it's yes, that this do actually correlate quite nicely. You'll be able to push that research on further, faster.
Yes, and we'll be able to just learn more quickly about how memories are formed and how they fall apart and what goes into forming a memory.
Amazing. So taking it back to Batman, obviously he is a law unto himself, and he has done some kind of invasive brain augmentation to be able to track some of these protein pops that we talked about before. So just to clarify and confirm exactly what he's got going on, he's looking around his cave. Please correct me if I'm wrong. He notices this mysterious rock unconsciously that's different in this very familiar environment. That protein pop occurs, and it's quite low level because maybe it's something that wouldn't normally get picked up. So because he has these amplifiers in his brain, that then external alarm is being triggered to say, this is a novel thing in your environment, you need to investigate it, and the day is saved. If you'd like to discuss your research on a future episode, email us at info@figshare.com.